do a brief intro just to make sure we are all on the same page in terms of using the GoToWebinar interface. So I'll see if we can start this up. There we go. So the first thing is that, as you have all probably noticed, you have this panel that has different sections to it. You can open and close it by clicking on the little orange button with a white arrow in it. You can set up your audio. If you're having any issues with your audio, make sure to open up the audio panel, set it to the appropriate device that you're using, either telephone or mic and speakers. And if you're using telephone, boy, this just never wants to advance my PowerPoint. If you're using telephone, you need to call in to the number that is indicated in your, sorry, my thing just froze up. The number that's indicated in your audio panel. Let's see, if you would like to submit questions during the presentation, you can do so at any time by typing them into the question panel. You don't have to worry about interrupting Mike, because I will be keeping an eye on the questions and passing them along to him during the presentation if necessary, but most of them we will probably save till the end. We will have time for Q&A at the end. Let's see, just in order to make sure that you can all hear me, it would be great if you would all click on this little button that looks like a hand with a green arrow. That's the raise your hand button. And if everybody clicks on that right now, then I can be fairly sure that you are actually able to hear me.
Welcome to GoToWebinar, webinars made easy.
And I'm actually going to check again to make sure everyone can hear me, because I just went off my my mic. So I'm going to put all your hands down and ask you all to click on the raise your hand thing one more time to make sure that you can hear me. Great. And feel free to send me a message if the quality of my sound is not good, although I won't be the one talking for the most part today. The other thing I wanted to point out, as you can see, my final little bullet here, is that the webinar is being recorded and it will be posted at VCGI's YouTube page. If I could get out of my PowerPoint, which I don't seem to be able to. All right, I'll just show you on our website. If you go to the event section and then the event archive within the event section, you will see the listing of webinars. And it will eventually get listed right up at the top here with a link directly to the YouTube page. You can also just go click directly to the YouTube page from the front page of our website. You don't really need to go through the archive, although you can. So right down here under my name is Connect with Us, and the YouTube link is right there. All right. I think that's all I need to point out. There, I saw a question here. I just want to check that. Okay, great. Ryan's letting me know he hears me. All right, so I'm going to pass things over to Mike now.
Good afternoon, everybody. Thanks for attending the webinar. My first, actually, so hopefully I won't bungle it up too bad. But we are going to be talking about the Vermont LiDAR Initiative, which is a recent initiative put together by VCGI and all of its partners to help facilitate gathering and disseminating LiDAR data in the state. So real quick, I'm going to give you a background on us, kind of from a structural standpoint, and then quickly we're going to get into the data and start talking about what's that? Oh. Hold on a second. There might be a possibility that I'm not actually online.
I think you guys are not seeing Mike. Hold on just a second.
It says I cannot take control.
Why would it say that? Well, how about if we just make you presenter? See if it'll do that.
Okay.
I promise you, all of you, that we practiced this yesterday and it worked just fine. There you go.
Okay.
All right, now you're all set.
I'm on. Okay. Sorry, folks. I'm going to start that all over again. Thanks for coming this afternoon to the Vermont LiDAR Initiative webinar. This is my first, so if I bungle anything, that's going to be my excuse. But today we're going to talk about our effort being that which is put together by BCGI and its partners to facilitate the acquisition and dissemination and use of LiDAR data here in Vermont. It was fairly well inspired by the events of Irene and the realization of the need for higher accuracy elevation and derivative data sets, and it has kind of gone from there. So let's see. Okay, so I'm just going to go give a quick background as to who we are, the Vermont EGC LiDAR Work Group, and what the Vermont LiDAR Initiative is. It is organized under the Enterprise Geospatial Consortium, which is an effort, it's a voluntary consortium of state organizations to more effectively leverage resources and make sure our efforts are all aligned. And that is the organizational piece for all the partners that you see down here, USGS, Natural Resource Service, and many others who are working together to get this data out to you folks as best you can. Let me just say, start it off, that we've created a LiDAR Initiative webpage, which is kind of the clearinghouse for all the available data and information relating to LiDAR. So I'm going to refer to this again and again because this has a lot of information in it. It has the Vermont State LiDAR Plan, which is our blueprint for acquiring and maintaining the data for the whole state. We also have a brochure, which you're welcome to print out and hand out to anybody that you're speaking with LiDAR about, whether you're giving a presentation and you just want to use this, or there's somebody you want to convince that they should support the acquisition of more LiDAR. And then we also have a map showing what's currently available, what is in work, which is being under contract right now, and that which we're about to be receiving, which is the Addison County data. Is going to be coming very shortly, I'm sure. All excited about. In a larger context, the national level, we're organizing our efforts underneath the National Digital Elevation Program, which is a consortium of 12 federal agencies. So we're going to start with the beginning question of what is LiDAR. It's an optical laser technology. There's terrestrial LiDAR and there's airborne LiDAR. We're talking pretty much about airborne LiDAR today because that's how all the data we have in our archive has been acquired. And if you look at this graphic, you can see that it's sending out these LiDAR pulses, and from each LiDAR pulse you can get multiple LiDAR returns. And those are classified loosely as just the first return. It'll bounce off the first thing that it hits, whether that be a tree or a building or a mountain or an open field. And then others will penetrate, say, through the canopy and hit the ground, and those will be ground returns and or last returns. Okay, so really this all starts with this kind of amorphous thing called the point cloud. It's really just millions and billions of points that are classified with whether the first, last return, or any number of the other classifications put up by the ASPRS. This is the point cloud representation of all the imagery you're going to see in subsequent slides, and it's pretty interesting because you can see, I was just talking about it, the LiDAR pulse will return off at the tops of the trees. Some of them will get down into the middle of the trees. Some of them will hit the ground. It's hitting buildings. It's hitting waste facility storage here on the farm. It's showing vegetation along slopes, and it's pretty interesting stuff. Now this is a graphic I put together to kind of help visualize what we do with the original point cloud data. And we basically create a container for all those individual files called the last data set, and then put it through some processing. And I'll show you a link to the Letters from the Sal blog, where Jarlath and Neil Dunn has put together a nice video that will show you how to do this in person with ArcGIS. But from these this last data set, you can extract just those points which hit the ground so that you can get that skin of the earth, bare earth digital elevation model. Or you can ask it to give you just those points which were the first returns. They bounced off the first thing they hit, and that gives you the surface model there. With these two kind of foundational data sets, we can create a bunch of the other derivatives. We can subtract one from the other. If we subtract the surface from the bare earth, we actually get height of feature, which is really useful information. And then we get the ones, other derivatives that we're all probably more familiar with, aspect, slope, contours, and hillshades. This is another graphic which kind of covers the same thing. We start with a point cloud. As I mentioned, you can query that in a bunch of different ways for the first returns or the ground to get either the DSM, the digital surface model, or the DEM. And if we subtract those, we get the NDSM. So now I'm going to focus in on this one extent. All the other slides that come after this, which represent the different derivatives, are going to be at the same extent. So you can kind of see it change from slide to slide. And what's really interesting is that when you look at these different derivatives, you really see the information in different ways. And it gets you thinking about how you can kind of put that all together in kind of one picture in your mind, and from there it can support any kinds of application analysis that you want to do. So I'm going to point out a couple of features here that are going to look different to you as we look at the different derivatives. You can see this fence line here, oops, this fence line, or possibly a stone wall. It's hard to know which it is from this bird's eye view. And we have areas here which are forested, and you might ask yourself, why are they forested and not cropland or hay and pasture field? And as we look at those other data, it's going to stick out a little bit more. The other interesting feature about this area is that this is the international border with Quebec. Okay, this is Richford, Vermont, and this is right on the border right here. So that has impacted how the land use patterns that are in place have come to be. Now the other thing I'll point out is that it's hard to tell which land here is higher elevation or lower. Is the house on top of the hill? Is it at the foot of the hill? It's really kind of hard to tell from this flat aerial imagery, but that's going to change as we get through some of the other data layers. This is the bare earth digital elevation model. It just shows those LiDAR points which actually hit the ground or classified as ground returns, and those are what were used to create this data set. So now the landscape takes on a little bit of a different hue than it did in the aerial imagery. You can see there's some relief here, which is where we saw those trees, and that's a very good explanation as to why it wasn't croplands, because it's too steep and probably always has been. We can see some drainage patterns. We see the roadbed, and we can see that that fence line is still there. So if it's showing up in the bare earth DEM, I'm going to hazard a guess that's actually a stone wall and probably not a fence line, because I don't think it would show up quite so well. Okay. Obviously, this is a higher, not obviously, I didn't put in a symbology legend here so you could tell, but the green is lower elevation and the white is higher elevation. So from the roadbed, it comes up, levels off this plateau, and then it comes down this way. Now, if you think about that in terms of how it would be represented in the other derivatives, say aspect and or slope, you're going to see that this is obviously going to be more north and northwesterly facing, and this is going to be southerly facing. Looks like there's a steep slope here, and again, another kind of outcropping over here. So it'll be interesting to see what happens with the rest of it. Now, using the first returns, we're able to get the digital surface model, and this paints quite a different picture, because now we can see the forested areas at that area of topographic relief. We see the actual barns and the farmstead here, all the different outbuildings. These could be stone walls. They could be those round hay bales stacked on top of each other. It's really kind of hard to know, but there's different level of information in this data set than there was in the other. Now, if you remember that overall graphic where I mentioned we could subtract the surface model from the elevation model just to get height of feature, that's what we end up with here. So in a way, we're no longer talking about elevation above mean sea level. This is just actual height. And you can see by the colors in the left, legend in the left here, some of these features are much higher than others. It makes sense that this is probably a more mature forest, so it's higher here. And the barns, does that make sense? The top of the barn, 7 to 11 meters, 30 feet. That sounds, like it could be about right. And what you're seeing with these vast swaths of orange are the overlap in points. When they fly, when the airplane is flying different swaths and capturing data, there's a certain amount of overlap it captures just to ensure that it has all the data. And I think that's the reason why you're seeing all those values jump out in that swath. Out here in the fields, there could be one point made it to the ground, one was at the top of a blade of grass or something, just showing that it's a foot or two tall. I don't really have a great explanation for this noise out here. But you can see that there are trees along that stone wall, and this is the building, the house, and some trees all around it. So what this can do for you is you have a height. If you also have, say, for example, if we're interested in biomass estimation, if you know what type of forest this is, and you know its height, you could probably make somewhat of a reasonable extrapolation as to how much biomass is there over a large area. This, I classified the aspect to be somewhat solar-oriented, so south being warm, and then, as you go up to more towards the easterly and westerly, and then more north-facing slopes, it kind of cools off, just to give you an idea, make the map make a little bit more sense. So this makes sense because we know there's a height of land here, so going from the road up to it makes sense. It's southeast and south-facing. These are all cool because they tilt towards the north. That all seems to be appropriate. And then we have the hillshade, which shows local illumination angles from the bare earth, and really this is used for cartographic reasons. If you want to drape the elevation model on top of this, it tends to give it a much nicer artistic feel. It also allows you to see the information a little more easily. So finally, we come to the slope grid. If you can remember, I pointed out in the original elevation model, it looked like there was some shading going on here, and sure enough, that's one of the steeper areas in this little data extent, as well as here where there are the trees that were growing along the border of the upper and lower fields. This particular derivative is in percent slope rather than degrees slope. So 100% slope is actually a 12-inch rise or a 12-inch run. It has the same amount of run as rise, whereas in a degree slope, that would be a 45. It's just two different ways to look at the slope, and we've chosen percent over degree slope. All right, now finally kind of putting that all together and using the last derivative here, the contours, 2-foot contours, that's pretty nice information. And it looks nice, and it's also quite a bit accurate than what most of us are used to working with. You can see this area over the barn. It just happened to drape on top of that. So, there's no way really to make this contour information draw underneath that barn unless I had a building footprint. So there are some things we are going to have to live with when we get this better information. So now I'm going to talk about how actually folks can access the data that we have. And before that, I need to go back and show when I'm talking about the access of data, it's really limited to the data that we currently have in our archive. We Essex County, Missisquoi, Upper and Lower, Rock River, it's also known as the Rock River. We do have the Chittenden County data. That's older data. It's 3 meters. It's not as highly accurate as these others, but it's still great data. Bennington County came to us not too long ago from the FEMA, courtesy of FEMA. And Addison County, which was worked on last year, is about to be delivered to us, and we're going to do some processing on that in terms of getting it into the Vermont Geographic Information System, and that should be available. Boy, I've gotten my tail stuck in the door on this one a number of times this fall, thinking it was going to become available, and it just kept bouncing back and forth between the vendor and USGS. But it is now on the table, and we'll try to turn it around in February to make sure that's available for you folks. And then this area, Rutland County, and also this is the last little stretch of the Otter Creek Subbasin got included, as well as the Mad River Valley, the Little River, and the remainder areas of the Champlain Islands. That's going to be, they started flying some of it this past fall. They're going to finish that up in the spring, and it does take quite a bit of time to classify all those points between first returns, last returns, grounds, and all that. So I don't know that we will get it before fall of 2014, but really that's a great big stretch there. That's 15% of the state that we're getting covered, so we're pretty happy about that. So on the download right now, we have the elevation, the DEM 1.4 meter. This is the Missisquoi Basin and the Bennington County. Those are the only extents covered right now. We're going to be adding Essex here pretty shortly, and also Addison as it becomes available, and the digital surface model. The other thing that we currently have available is the all LiDAR product, which is basically the kitchen sink of LiDAR that we currently have in our archive, and we put it all on a 2 terabyte external drive and sell for the cost of the drive, basically. So that data, the product takes all of the vendor data, and we normalized the naming convention, the projection, the file structure, and the schema to make it a little more user-friendly, because each different project extent had different requirements and delivery specs. So we took a whack at making that a little bit easier to use and normalizing some of those characteristics. As for, this is the future idea, we were talking about it today, making services, both feature and image services, out of the LiDAR data, so you could just, use it over the internet, don't have to download it, don't have to symbolize it or whatever. I'm not going to help you with disconnected editing if you're out in the field with certain applications, but should help quite a large pool of the users out there to make things a little bit easier and give you yet one more option to access the information. The source or last files that the point cloud data is stored in. Right now, you can get Essex and Missisquoi through the USGS Earth Explorer interface. I don't want to say it's hard, but it's not easy. It'll take a little bit of doing, and you'll have to live with the data in the source projection, which changes for each project area, and also the tiling extent that they use. So if you do want those, if you don't want to pay for our brick, you do have the option of getting those 2 project extents for Earth Explorer. And at some point, we are probably going to forward all of our, or we will forward all of our last data sets to the NOAA Coastal Services Center, because they've offered to host all that data for free, and that would give folks yet one more option to download the source last files if they want to do any custom processing. Also, Open Topography is an archive that you can access this data from. Perhaps Jarlath Neil Dunn of the UVM Spatial Analysis Lab can speak a little bit more about that when we get into an open part of the presentation, as he's worked with that. But it's hosted by the University of California, San Diego, and the San Diego Supercomputing Center in affiliation with Arizona State University, and it's funded by National Science Foundation. So real quick, I'm going to talk about the accuracy of these different project extents, and I can show you that this area right here is data quality level 2, data quality level 3, 3, and 3. These are going to be, I believe, 3, and this is going to be quality level 2. Now, what does that mean? That means that how those LiDAR pulses, how many points they get per square meter, so how many pieces of information you're going to get back for each square meter. Obviously, the more, the better. It's going to give you more information. So from QL3, which is what most of our archive is in right now, you have between 1/4 to 1 point for every square meter. And vertically, those are accurate to equal to or less than 18.5 centimeters, so 2/3 of a foot vertically. Pretty good stuff compared to what we've been used to working with. And moving forward, incidentally, the QL3 is also equivalent to the but the USGS LiDAR base specification that was used prior to these quality levels being homogenized and adopted by the National Digital Elevation Program. But moving forward, all the data is going to be acquired at quality level 2, if, who knows, possibly even quality level 1 in the future if the price comes down or the need is great. But generally, what we're looking at is darn good data compared to the 10-meter elevation model that we had before. I just wanted to throw this up. I'm not going to get into this too deeply, but you can see from the different licensing requirements what you can do with the information. And I'll say that since we're already taking these last files and processing them for you, most of this is going to be a moot point unless you want to do some stuff with terrain data sets or some more advanced processing. Then you might need either 3D analyst or the spatial analyst to do that. But with standard just desktop GIS, you can view everything. You can convert the last to a raster. You can run different raster-based analysis against the last and mosaic data sets, and you can even edit the data scheme. So I think for the most part, if you only have the ArcGIS standard desktop license, you're going to feel like you're in pretty good shape unless you really start getting into some custom stuff. And also, there are other tools out there. We're going to touch upon those briefly. Some have free versions. They're mostly viewers with reduced functionality. If you really want to get into heavy processing of the point cloud data, I'm going to get in trouble by Esri by saying this, but based on my own personal experience, I would say don't do it. Take the data that we've created for you, and then step forward from there and apply it to your efforts. Okay, real quick, in terms of resources, the two top-tier Esri help resources that I've come across are using LiDAR and ArcGIS. You get this whole, you can see it's under geodata, data types, last data set, LiDAR support in ArcGIS, and this one down here, LiDAR solutions in ArcGIS. If you want to educate yourself on LiDAR more, I would say focus in these areas, and you'll probably get a pretty good return on your investment. Okay, this is where I spend most of my time, so I just wanted to point that out. As I had mentioned earlier, there's a good video, a number of videos that our LiDAR friend, Jarlath, has done. Now I lost it. Here we go. Up at the EVM Spatial Analysis Lab. And he's posted it here, so you can see a YouTube video of how to create a DEM and a DSM, and also do the math to get an NDSM. And also, there's a bunch more here. I've spent a lot of time in here, just reading up on different things. He's got different, different videos from a bunch of different topics related to LiDAR that you can spend all kinds of time with. So I just wanted to point out this good Vermont-based resource. Others are, I think I mentioned Earth Explorer is a place where you can get both the data and the last files. NOAA Digital Coast, they do have some tools. They're also going to store our last information. There's a news website for LiDAR, details on the quality levels that I talked about. And I also wanted to mention real quick, I'm going to show you this other PowerPoint, which is available on our website in the Events Archive section. But this, one thing I did not really talk about is how you can process the DEM relative to these different hydro treatments. And I'm not going to go into this too far, but there's a number of different ways you can deal with how these flatter areas, like usually water bodies or flat buildings, can be addressed. And often these aren't necessarily part of the delivery, although they will be for Addison, because they are intensive and therefore post-processing intensive and therefore expensive. But they're incredibly useful for doing hydrology and hydraulics, watershed modeling, all those water-related types of analyses, and you can see the different results that you're getting from these different efforts. If you want water to flow and you've got a culvert, you've got to make a break in that surface, so the water's all going to come down here and flow like the proverbial raindrop. Okay. All right, and then in these quick terrain modeler videos, these are pretty good. I checked out a few of them. I think Mr. O'Neill Dunn has done some or all of them. Check them out. It's a good, quick way to get yourself up to speed on how that point cloud data is used and how you can derive a number of different derivative data sets from it. In ArcGIS, if it works, I'm going to show you real quickly this one tool I find really useful. But to do anything heavy with say 3D visualization in ArcGIS and LiDAR related derivatives or any elevation model derivatives, you need a 3D analyst. But you can do all of your regular map algebra or any raster-based processing, limited to maybe the need for spatial analysis for some of that in ArcGIS otherwise. But I will try to show you this one that I found very useful. So I wanted to show you, this is just some extracts from the data sets that I think will help reinforce the idea of how this information is collected and how these first returns versus ground returns and last returns. It just gives you a very visual way of trying to make sense of something that's very abstract. And look at this, you can see right here where the points didn't even reach the ground here because the tree was dense enough that it intercepted all of them. Excuse me. So an application, business case use for LiDAR, which is really interesting and probably would have been really helpful 3 or 4 years ago when the state was going through this ancient road issue. But from looking at the bearer of DEM, it looks pretty clear that that was an old road. You can even see there's a stone wall here. There's probably a 4-wheel drive path over here. Looks pretty clear, right? Well, if you blink your eyes for a second, and if you just look at the digital aerial photo, I mean, can you really see where that is? You maybe can see a little bit of a road up here or down here, but it doesn't really jump out to you, until now I'm just draping the ortho on top of the bearer of DEM. All of a sudden it becomes pretty clear that a fairly substantial road used to go through or still goes through there. So interesting use of the data. So this next one is near an area where I frequent often, visiting a family house, but this is a snapshot from the De Beers Atlas in 1856, and it shows the Ward Lime Works. And interestingly enough, I drove past this for about 18 years, never even looked at it twice, never even knew it was there. But just to show the power of you don't see anything unless you're looking for it, there it is. It was 100 feet off the road, and boom, it didn't really take much looking to find it. So this lime kiln, they used to get a limestone and cook it in here and use it in 2 applications. They would either use it for spreading lime on the field or for a lime to put in mortar mix for making concrete. And in talking with one of my wife's family's friend who was about 91 years old, she said, "Oh yeah, my grandfather had 3 or 4 of those on his property." So it's just an interesting insight into history. And this is what it looks like on the elevation model. So you can readily see that they mined the rock from up here, and being smart Yankees as they were, they went downhill with all that heavy rock down to the lime kiln and then processed it here and then took the finished product offsite. So I am going to take this into a more of an open arena, and I'm going to call it a lightning update. If anybody has any news they want to share about what's going on now that the legislature is back in session, and we've tried to make some efforts this past fall to advocate for supporting some funding to capture the rest of the state. Or if you have any interesting applications or know of any interesting details about data development, I'm going to encourage you to raise your hands, and Leslie will open the draw gate and let you into the verbal realm of the webinar, and then tell us what you know. So if anybody has anything to kick in there, please please step forward. Jarlath, if you're out there, perhaps I can poke you to go first and tell us a little bit about what you've been up to lately.
Sure, Mike, I'd be happy to. So this is a great presentation. One of the points I'd like to make, and I think the advantages of getting those LiDAR surface models from VCGI as opposed to doing it yourself, as we're working with VCGI to do a cross-tile processing. So we were fortunate to get a grant to do this, and that's a little bit different than processing each LAS file yourself, because when you interpolate the surface, obviously if you just do a tile, you can sometimes get little edge effects, so we're interpolating across those tiles. So this is different than just taking each LAS tile in ArcGIS and running batch scripting. We're using some different tools to allow us to take hundreds of millions or sometimes billions of points, virtually stitch them all together and create a seamless surface that way. So that's something that's, I think, of benefit to you folks. Those of you that were on the Vermont GIS listserv the last few days, there's discussions about maintaining depressions and things like that. Obviously, if you're going for a specific use case and specific type of feature analysis, in that case, it definitely behooves you to go back to the point cloud, and you might want to play around with some of the different settings out there, because the settings that we use for sometimes generating these general surfaces may not be the ideal ones. For example, if you need to get really precise building edges or see some of these very interesting geologic features across the landscape. The third thing, and we'll have more news on this later in the spring, I think, is that we'll be working with Leslie Pelch at VCGI. We're going to do a little 2-day remote sensing summer camp up at UVM this summer. Our primary target audience, based on our funding source, which comes from AmericaView, is going to be RPC and state employees and maybe some town GIS folks as well. We'll see how we do with those groups, and then we'll open it up. But we're looking at a 2-day workshop. All you have to do is show up. You'll get to use our GIS lab. First day we'll look at doing some sort of image processing things, and then the second day we'll focus on LiDAR. So you'll get access to a lot of the LiDAR tools. We'll show you how we build these products and also look at some of the types of analyses that you can do. And so once again, we'll work with Leslie Pelch at VCGI and get you an update sometime, probably the March or April on that front. So that's what I have from my end, Mike.
Okay, thanks, Josh. Anybody else? All right. Well, I'll tell you what. I'm going to take the moment to show you folks one tidbit I did want to point out in ArcGIS. Assuming everybody can see my ArcGIS map now. If you under the windows, I believe this to be at the standard desktop level. But if I select DM image analysis, and you wouldn't think this is just sitting underneath the Windows tab. But once I found this, it was like, oh wow, it makes symbolizing this so much easier. You get into this subsequent dialog. You have to make sure you pick the one you want, and then you notice that the other dialogues become active. If I just click on this, this is going to give me a super quick, very nice image, which is basically, I guess, what you saw in the PowerPoint. And that's a whole lot easier to read visually and infers a whole lot more information than that does. So that's the one quick tidbit I wanted to throw out about ArcGIS that I have there. There's some information here, I'm sorry, one suite of tools, the last data set tools. I'm not going to demo that right now, but just wanted to point that out as well. Okay, so let me get this off the...
Jonathan Croft at some point indicated that he would like to speak, but I think he has a little technical issue. Oh, wait, maybe not. Hold on.
I think I'm on.
You're on, all right.
You're on.
Good afternoon. This is Jonathan Croft, and I just want to let folks know that I did go down to the House Transportation Committee this morning and talked about LiDAR and how we're using it at VTrans. and also just gave an overview of what data is already out there and how the consortium is working collaboratively to try to collect LiDAR statewide, and what the plan is to try to get the remainder completed. So I think it was a very, very good discussion, and I've got to go down to the Senate, and some folks came back today and said they were asking about LiDAR again. So I think there's a lot of interest, and we definitely see a lot of value in this imagery data.
Fantastic. Well, thanks for continuing to advocate for it, Jonathan. We'll take all the good press we can get.
Mm-hmm.
Okay. Is there anybody else that would like to speak up and share any information at this time? Maybe I'll keep an eye on this, so if anyone does decide they want to share, just click that raise your hand button. In the meantime, this is a great time to start sending your questions if you have any. There are a few questions. Mike, can you see the questions? You open up that little question panel.
Oh, yes, questions. I guess that's my first. I see it, but it's showing in an incredibly small box.
Yeah, you can actually pull that box out and expand it, but I can read it to you if you want.
Okay. Oh, all right. Well, okay, got it out. I just need to make it bigger.
There you go. Just drag it.
Okay. All right. There we go. Now I can see what's going on. Okay. So, what physical features do you think makes the international border show up on the Bare Earth DEM? Primarily, it's the fact that they cut an open area. That's the first one that I see. But maybe it sit back up there. There we go. So I think they have an access road in here. I don't know if they have cameras in there, or it's a patrol section, or they keep it open for vehicles or not. But I picked this area primarily because the farm was compelling and the relief was compelling, and it just happened to be on the border. I was like, oh, that's even more cool. So I thought it was a good extent to show. Yeah, I think it's predominantly the ground cover and the fact that you can see it so strikingly in the digital surface model that really makes it stand out. Yes, to image services. Okay, yes, we talked about that this morning. Once we get the Essex and Addison County data squared away, Essex had an issue where we were missing a quarter quad of the source point cloud information. We know it existed at some point because there's a elevation model in that area, but without the point cloud, we can't pull off the digital surface model for it, and therefore we can't get the height of features for that one area too. So we've been working our way through that, and I think we've come up with the best solution as is possible, and we're going to move forward with that. And then when we receive the Addison County data next week, we basically chop it up into a set ortho 9 tiling structure. So that's 9 orthos on a side, or 36,000 meters by 36,000 meters. And once we process that and get the metadata squared away, we'll upload that to the ArcGIS server and then make it available through the web. And at some point in the future, we'll be able to build mosaic data sets and services off of that. Okay, so the Mad River Valley date. Well, John, that's a question near and dear to my heart because I live in Waitsfield, and I'm drooling to get my hands on it as well. They flew in the fall because, this is neither here nor there, but unfortunately they had really good weather in mid-October when they were originally going to start, but the government shutdown kind of put a big squash on everything. And then once that reconciled in late October, they had just enough time to fly the islands and the Lake Champlain coastline area of that project extent because they wanted to get the low lake levels that are, usually what happened in the fall. You don't want to do that in the spring because the water can be very high, as we've seen over past years. And then late October, we had some snow in the higher areas of Rutland County and certainly at my house in Waitsfield, so that pretty much put the kibosh on finishing any more this past fall. So now they're going to have to wait till snow melts in the spring, which we all know can be March 1st through May 1st. And once they acquire the data, as I alluded to earlier, there's a whole lot of post-processing that they have to do in order to tease out which points are ground returns, which ones are first returns, which ones are last returns, and because everything flows from those classifications. If you don't have those points classified, you cannot accurately make elevation models and digital surface models and all the derivative downstream products from there. So they've told us they're not going to release data in pieces, because if you did that, and say if they just had the data they've flown and processed it and disseminated it, and then when they went and flew the rest, somebody would have one version of the data, and then there would be an edge match issue once they added the other version of the data. And it really, I understand from a data processing standpoint, which we're involved with quite a bit, I understand why they don't want to do that. And it's too bad that we're going to get it earlier. But because of all that processing time involved, and then they have to submit it for quality assurance, quality control to USGS and have it be accepted, I would say at earliest late summer, more likely in the fall, and then we'll turn that around as fast as we can and get it up on the VGIS. So sadly, I know you don't want to hear me say October, November of 2014, but I'm going to give myself a little leeway on that based on the Addison County data, which I made some maps that were, turned out to be inaccurate for a couple months, and that caused problems, so I don't want to repeat that process. Okay, I think that's all the questions I can see.
Hey, Mike.
Yeah.
There was another question on there that I don't think you answered. It's really directed towards Jarlath. I don't know if you see that.
Have you?
And I'm.
Oh, yeah. The UAV. Yeah, Jarlath,
Right,
you want to jump in real quick about gathering LiDAR data with your little airplane?
So I'm going to unmute Jarlath again, but I also want to point out that after he answers that question, I'm also going to unmute Lynn Neifert, because he would like to give a little update.
Great.
So go ahead, Jarlath.
Sure, yeah. Thanks. Yes, it's Jarlath O'Neill done again. So we do have, as part of a transportation grant, we've been working with VTrans to acquire point cloud data using a small unmanned aerial vehicle. This is made by a company called SenseFly. It's known as the EB. And so it's not actually LiDAR data. What we do is through stereo photographs, we can derive point cloud information. So it's definitely not a replacement for LiDAR, but what we think this tool is going to be primarily useful for is remapping areas where there's been LiDAR. So you have a stream channel, perhaps it's changed due to flooding. You've got a small section there, maybe a kilometer or two. You want to go out and refly it, you can do that. So we hope to have more up on the letters from the SAL blog soon. Everything we do has to be approved. Any tweet, any blog post by our friends at the Department of Transportation. So the dissemination cycle is a bit slow, but we've had some good success with our friend Jonathan Croft there going out and flying the Morrisville truck bypass and doing volume estimates from it. We did volume estimations compared to ground-based LiDAR and found we're within 5% of the actual volume. So it looks like a pretty accurate tool. Once again, not the same as LiDAR. But for certain instances, when you have small areas and you need a point cloud data and you've got clear visibility to the ground, it's really a novel solution. So look for more of that down the road.
Okay, thanks, Jarlath. Lynn?
So actually, it looks like Lynn is not connected right now, so we may not be able to get Lynn on. Sorry.
Okay. Well, let's perhaps to buy him some time and reconnect if he's having any problems. Might be time to open this up for any general questions and hopefully some answers. So please raise your hand if you have any general question whatsoever, or even if you have an idea of what you may want to use LiDAR for, or if you have a really interesting use case for LiDAR that we may not have thought about. We're just going to open session. Please feel free to ask any question or inform us of anything interesting related to LiDAR.
So this is Leslie again. I'm going to ask the first one. I'm actually going to ask Joanna Grossman's question for her, just so I don't have to turn my computer around for her to ask it. But her question had to do with your demo at the beginning, and why is it, or how is it that is it the bare earth? Yeah. The bare earth data seems to basically see through or go right through the barn. Why is it that you don't see the barn at all in the bare earth data? Or I guess there is something there, but
this perplexed me for quite a while, and I'll take any backup I can get on this if I misspeak. But I believe the only way that let me say this a different way. I believe what you're seeing here, where the barn is, you see how there's some, I call it tinning. There's some striated lines going back and forth. It's the same thing you see in streams and rivers and lakes, because water tends to absorb the LiDAR pulses. I'm not saying that the barn does, but it's just that what happens in rivers and ponds is you get, basically you don't have enough information to make accurate estimates from, and it does this kind of tinning back and forth. So what I think is happening is that there are points being picked up around the edges of the barn, and those are being classified as ground points, and there are no points in the middle, so it takes the information around the edges and extrapolates across that open surface. Same with houses. Can you really see the house in here? You can sort of see it. But I believe that's what's happening, and if anybody knows different, please feel free to educate me, because that's the best explanation I think I have.
And I'm unmuting Jarlath just in case he feels like adding anything to that.
Well, I think Mike nailed it there. And the key thing is this is where if you're doing certain types of analyses, you may want to play around with the interpolation algorithms to deal with these no data areas. So that area under the barn is a no data area. So like Mike said, it's stitching or creating a surface using the surrounding points. And so you'll see this triangulation in water bodies, under buildings, and things like that. And it can be less than ideal. And the techniques needed to fix these things up, they're certainly out there. We won't be doing it for the products we're generating for distribution because it's a lot of extra processing. But it certainly can be done. You can flatten these areas, and we've done that for other projects. It's simply a cost and time issue.
Yeah, what I'm showing is I'm going back to the Lynn Neifert's hydro treatments PowerPoint, because this is exactly what happens in areas, big flat areas. You see this tinning going back and forth, and what they can do is, with the advanced extra processing that Jarlath just alluded to, is smooth that out and get rid of it. Same up here at the top of a building. They've gone in there and smoothed that out. So it can be done. It's just it's a lot more processing, therefore a lot more money. And when you start looking at hundreds or possibly over 1,000 square miles, and the dollar figure per square mile goes up quite a bit, possibly even doubles. That's why you basically live with what you get, and be happy that we have the really accurate information that we do. All right. Anybody else have any more questions? All right. While I'm waiting to see if anybody else has anything comes to mind, let me just point out that our other webinars this winter all seem to be, LiDAR seems to be a really prominent popular theme here. So although I know some had asked me today, oh, am I going to learn how to use LiDAR better? My answer was yes and no. I hope that you'll be able to use it better by understanding its source and how it's derived and how they're all interrelated. But there are other webinars coming up over the course of the next, this month, February 5, 6, and 19th. There's a bunch coming up, and I think it's really going to round out knowing where it came from, the Vermont LiDAR Initiative, knowing some more in-depth details about the LiDAR data, how you can use it for public works, and then some tips on working with it within ArcGIS that Jarlath O'Neill Dunn's going to be able to present. So it's great. There's a lot of resources here for free, and hopefully people will be able to take advantage of them. And other things that I can think of off the top of my head are that Leslie and I are going to be at the State House February 11th. Is it, Leslie?
Yes, it is.
and we're going to be in the alcove by the cafeteria. I forget what that's called. But,
The card room. Yep.
Feel free to stop by. We'll have some apps and computers, and we'll have some data with us, and we can talk tech. And if you're lucky and your house has got LiDAR coverage, we can zoom in and check it out. And also, offhandedly, I'm thinking about other things related to LiDAR. There's going to be at the GIST, perhaps Jonathan, you can speak to this. I think it's your coworker who's going to be presenting on archaeology and using LiDAR and archaeology. That sounds like it might be a really interesting presentation. So I believe that's in early May up in Burlington. So,
Hey, Mike, there's a couple more questions that just came.
Okay, great. Let me learn how to sort them by time. When I load the Chittenden County LiDAR bear with DEM, I notice the raster represents the terrain as sort of terraced as opposed to a continuous terrain surface. Is that a known issue or something with my loading of the data? Okay, so it's the bare earth. I've not worked with the Chittenden County data enough to know the difference. That's kind of in Jarlath's backyard. So, Jarlath, if you know exactly what she's asking and want to address that, I think I would refer that one to you. If you're still here.
I am still here. I just missed the question, Mike.
Oh, I'm sorry. Blaine has asked, when I load the Chittenden County LiDAR bare earth DEM, I notice the raster represents the terrain as sort of terraced as opposed to a continuous terrain surface. Is that a known issue or something with my loading of the data? That could be that area has been, modified by, human-made efforts. I don't know why that would be, or it could be a series of old different flood zones on the river over the course of time. But
Yeah. I think we'd have to take a look at that particular issue. So the Chittenden County data was delivered in CAD format. And so I think when we got it, there's all sorts of crazy stuff we were doing, like first getting it to shapefiles. This was back, of course, in 2004, and then going from shapefiles to raster and things like that. So we might want to take a look at that area. I think it could be the processing, or you're right, Mike, there could be some actual features there. But the Chittenden data was sort of very early in the world of LiDAR, so the processing, the post-processing done by the vendor is nothing nearly as good as what you would see nowadays. And sometimes in those early LiDAR data sets, even on flat surfaces like roads, you see these interesting billowing effects. Makes it look like there's snowballs on all the streets and things like that.
all right. Well, let's see. I'm going to see if I can pull this off live and kill two birds with one stone. I have a question about the tool used in image analysis, but I've also been given the actual tile. That is the tile in question. So let's see if I can pull this off, and hopefully I can. Yeah, I guess I'm not going to know which show tiles. And then I'll use I'll answer the other question and, excuse me, say which one, 0317. Okay, there's two different tiling indexes going on, so I'm not gonna hazard that one. Sorry, Blaine. I'll be happy to address that offline and see what I can find. Okay, so the other one was what tool is used for image analysis? In the Windows tab of ArcGIS, it's just the image analysis tool. And if you click that and then pick the target raster here, then you can come down. You can pick any color ramp that you want. I tend to default to the one that it uses, and frankly, I don't mess around with all these different options. I just click on that, and I'm pretty happy with what I get for the most part. The colors aren't perfect, but it applies a Hillshade to it, and it's a really super quick, easy way to get a pretty good looking map without a whole lot of hand-wringing and mental push-ups. So that's one of my favorite tools I've found with working with this data. Okay, so we are at 2:30. Unless I don't think there's any more questions here, I'm going to hand it back over to Leslie to do wrap up, I think. And thank you for your time. I appreciate you coming. And I would also say that certainly feel free to contact me. Anything LiDAR, I'm happy to talk about. Anything we can do to help you out along those lines, that's what we're here for. My information is up here real quick. Just Mike B at vcgi.org, or give us a call, and we'll go from there. Okay, thanks a lot.
Thank you, Mike. And I will just remind everyone that this is being recorded, and it will be posted at the VCGI YouTube page, which you can access either directly from the link on our front page or from the event archive. If you go into the event area of our website, you'll see the link to the event archive. Both of those just take you to the YouTube page, and you just search around for the one that you're interested in. I will also post the PowerPoint that Mike used at the event archive, so that will only be posted at the event archive. So if anyone has any other questions, you can see that you can direct them to Mike, and he'll be happy to answer them. So thank you very much, everybody, and have a good day.